Okay, starting with example 16-13. Can you see the figure of example 16-13?
Yes.
थोड़ा सा wording इसमें मिस हो गई है, मैं इसको नीचे कर लूँ. ओके, इसमें है क्या कि you have three rigid bodies. One is a roller A or a rigid body A. The other one is rigid body B. And both these rigid bodies A and B are constrained to move along the inclines as shown to you in the figure कि 45 degrees की incline पे ये move कर रहे हैं. Then you have a rigid link which is connecting these two rollers. This link AB, it has a length of 10 meters, and this rigid link is connecting point A and point B with each other. So let us read the statement first of all. The rod AB is confined to move along the inclined planes at A and B if point A has an acceleration of 3 meters per second square and a velocity of 2 meters per second down the incline. At the instant this rod becomes horizontal, you need to determine the angular acceleration of the rod at the instant shown. So the kinematics of point A are known to you. That is, it is moving down with a speed of 2 meters per second and an acceleration of 3 meters per second square. You need to determine what is the angular acceleration of this rod AB at the instant shown when this link AB becomes horizontal. Both the inclines are at an angle of 45 degrees as shown to you in the figure. Now, since omega is not known to you here, and in order to apply the relative acceleration equation, you will be requiring that omega. So it means that first of all, you need to perform the velocity analysis, and then you are going to perform the acceleration analysis. Okay, before proceeding on to the velocity analysis, what type of motion this link AB is undergoing?
जनरल प्लेन मोशन.
जनरल प्लेन मोशन, चूंकि आपको नजर भी आ रहा है कि जो नेक्स्ट इंस्टेंट आपको दिखाया गया है इस पे ये लिंक ए बी ना सिर्फ ट्रांसलेट हुआ है बल्कि साथ साथ रोटेट भी हो रहा है. सो इट मींस दैट इट इज अंडरगोइंग जनरल प्लेन मोशन. सो इन ऑर्डर टू अप्लाई द रिलेटिव वेलोसिटी इक्वेशन, बेस पॉइंट हम किसको बनाएंगे?
सर
ए को बेस पॉइंट बना लेंगे. सो अवर इक्वेशन वुड बिकम VB शुड बी इक्वल टू VA plus omega cross R. So omega is going to be omega AB of this connecting rod, and the relative position is going to be the relative position of B with respect to A. Okay, what about VA? Can you identify this VA vector?
Yes sir, given है 2 meter per second.
But we need to write it in vector form.
सर वो 45 डिग्रीज के साथ इसको लगा देंगे.
So fourth quadrant है positive x, negative y. So this vector would become 2 cos of 45 I minus 2 sine of 45 j, isn't it?
Yes.
Okay, what about omega AB? Can you identify this omega's direction?
Yes sir, counterclockwise.
It is counterclockwise, so we can write it here as omega AB k. And what about RBA vector?
Sir, 10 I hat.
So it is going to be this vector, and it has a magnitude of 10 units directed towards the positive x-axis if you are using conventional xy coordinate system. So it is going to be 10I. Taking this cross product, the right hand side would become 1.414 I minus 1.414 j, and omega cross r जो है वो अगर हम वही I j k consider करें, it is going to be plus 10 omega AB, and k cross I is j, so it would become 10 omega AB j. So I hope that the right hand side is clear to all of you.
Yes.
Okay, what about the left hand side of this equation? It represents the absolute velocity of B, although you don't know its magnitude, but you know that once point A is moving downward, point B would be moving up that incline, isn't it? So the direction of VB is known to us, that is, it is going to be at 45 degrees with respect to x-axis. So can we write this VB vector? क्या होगा ये VB vector?
VB cos 45 plus VB sin 45 I hat j hat, दोनों positive क्योंकि first.
So since it is first quadrant, VB cos 45i plus VB sin 45j, ये आपके पास VB आ जाएगा. So it is a vector equation, so you are going to compare the I and j coefficients on both sides of this equation. Once you compare these I and j coefficients, you are going to get the values as VB comes out to be 2 meters per second, whereas omega AB, which is required for applying relative acceleration equation, so this omega AB comes out to be 0.283 radians per second, and it comes out to be a positive quantity. So our assumption is correct, and this link AB is rotating in a counterclockwise direction. So you have completed this velocity analysis, and you have determined the value of VB and omega as shown to you here. Is this point clear to all of you?
Yes.
Okay, so once we have found this omega, now we can move towards the acceleration analysis. Now, in order to perform the acceleration analysis, we are going to apply, since we have discussed that this link AB is in general plane motion, so we are going to apply the relative acceleration equation on this link AB. What should be that relative acceleration equation? Base point हमें किसको बनाना चाहिए? So since the acceleration of A is known to us, so we are going to make A as our base point. So the equation would become acceleration of B equal to acceleration of A plus alpha cross R minus omega square R. Here alpha is going to be the angular acceleration of this link AB. R is going to be the relative position of B with respect to A, and omega is going to be the angular velocity of this link AB. So this is the relative acceleration equation being applied on link AB, which is in general plane motion, taking point A as our base point. Okay, we need to write all these things in terms of vectors. AA, can you identify AA vector?
Yes, sir. Fourth quadrant में 3 cos 45 minus 3
3
sin
cos
45
sin 45j, ये आपके पास वेक्टर आ गया AA. Okay, what about alpha AB? First of all, what does this alpha represents? Alpha है क्या ये?
tangential acceleration.
It is the angular acceleration of link AB. अच्छा, अब angular velocity तो आप कुछ common sense के साथ जज कर सकते हैं, but can you judge कि ये angularly accelerate हो रहा है या decelerate हो रहा है? Can you judge it?
No, sir.
So if you cannot judge it, you are always going to assume it in a counterclockwise direction. Solve it. If the sign of alpha after solution comes out to be a positive quantity, that means your assumption is correct. If it comes out to be a negative quantity, that means you are going to reverse your assumption. So alpha judge करना possible नहीं है. Omega तो आप judge कर सकते हैं उसकी motion को देखते हुए कि अगले instant पे कहाँ move कर रहे हैं, लेकिन alpha जो है वो आप judge नहीं कर सकते. Therefore, always assume alpha to be in a counterclockwise direction. Solve it. If the solution comes out to be a positive quantity, आपका assumption correct है. If that solution comes out to be a negative quantity, then you are going to reverse your assumption. So accordingly, जब आप alpha cross R लिखेंगे, तो यहाँ हम इसको alpha AB K के तौर पे जो है वो assume कर लेते हैं. Is this point clear to all of you?
Yes, sir.
Yes.
Okay, what about RBA? We have already discussed it. It is basically 10I. So आपके पास alpha cross R ये हो जाएगा minus omega square R. So minus 0.283 जो हमारे पास omega की वैल्यू आई थी. अब यहाँ देख लें इस इक्वेशन में omega is basically स्केलर वैल्यू आपने इस्तेमाल करनी है. बाकी चीजें वेक्टर हैं. ओमेगा जो है उसकी स्केलर वैल्यू आपने इस्तेमाल करनी है. So it is 0.283 square into 10I. Is this equation clear to all of you?
Yes.
So once you further solve it, this would become 3 cos 45 would become 2.12. So 2.12I minus 2.12J. Alpha cross R के लिए आप वही smaller circle इस्तेमाल कर सकते हैं. It would be 10 alpha AB. What is K cross I? It is J. So आपने इसको +10 अल्फा ए बी जे के तौर पे लिख लिया. इसी तरह 0.283 को स्क्वायर करके जब आप i के साथ मल्टीप्लाई करेंगे it would become -0.8 I. So the right hand side of this equation would become like this. Okay, what about the left hand side? What does this left hand side represents? It represents the absolute acceleration of B. So since point B is constrained to move along the incline, so you can write this AB in terms of vector as previously जो आपने VB के साथ किया था. So AB can be written as AB cos 45 I plus AB sin 45 J. So this is going to be AB, which is AB cos 45 I plus AB sin 45 J. और cos 45 या sin 45 0.707 होता है. So 0.707 ABI plus 0.707 ABJ should be equal to 2.12 minus 2.12J plus 10 alpha ABJ minus 0.8I. Okay, now since it is a vector equation, so you are going to compare the I and J coefficients on both sides of this equation. So once you are comparing the I coefficient, it means that 0.707 AB should be equal to, on the right hand side it is 2.12 और किसके साथ आई है?
-0.8.
-0.8. So the I coefficients equation would be like this. When you write the J coefficients equation, on the left hand side 0.707 AB should be equal to -2.12 plus 10 alpha AB. ये आपके पास दो equations आ जाएंगी by comparing the I and J coefficients on both sides of this equation. Once you solve it, the value of AB comes out to be 1.87 meter per second square, and accordingly the value of alpha comes out to be 0.344 radians per second square. So alpha आपका positive आया. इसका मतलब क्या है कि this alpha is acting in a counterclockwise direction. What was the direction of omega जो आपने इससे पहले velocity analysis में निकाला था?
Counterclockwise.
वो भी counterclockwise था. So alpha and omega have come out to be in the same direction. So what does it mean?
Accelerate हो रहा है.
The body is angularly accelerating at this moment. Is this point clear to all of you?
Yes.